What if the oldest, most distant machine humans ever built is about to go silent forever and only a handful of engineers can stop it? Right now, in a quiet room in California, those engineers are preparing a move so dangerous they refuse to test it on the spacecraft that actually matters. Before we go deeper into this story, do me one small favor. If you love space, science, and the incredible things humans have done, hit that like button, tap subscribe, and share this video with one person who would find it fascinating. It helps more than you know, and it keeps stories like this alive. Now, let's get into it. Somewhere inside NASA's Jet Propulsion Laboratory in Pasadena, a small team is staring at a problem that has no easy answer. They are trying to save Voyager 1, and they are running out of time. This is not a movie. This is not a simulation. This is happening in the real world right now, to a real spacecraft that is drifting through the emptiness between the stars. And the plan they have come up with is so risky that if it goes wrong, it could kill the mission instantly. They call it the Big Bang. Not because it sounds cool, not because it has anything to do with the birth of the universe. They call it that because of what it actually does. It is a single, sudden, all-at-once change to how electricity flows through every living system on the spacecraft. Think about that for a second. They are not going to fix one thing carefully. They are not going to turn things off slowly and safely, one step at a time. They are going to flip everything at the same moment. One command, one shot. No do-overs. And here's the part that makes your stomach drop. Voyager 1 is so far away that a single command takes almost a full day to reach it. Then the answer takes almost another full day to come back. So when the engineers press send, they will have to wait nearly 2 days before they even know if the spacecraft is still alive. 2 days of silence. 2 days of hoping. 2 days of praying that a piece of technology built before home computers existed will cooperate one more time. To understand why this is such a big deal, you first need to understand what Voyager 1 really is. Forget the poetry for a moment. Forget the golden record and the beautiful idea of a message drifting toward alien worlds. Let's talk about the cold, hard facts. Voyager 1 is currently about 16 billion miles from Earth. Let that number sink in. 16 billion. It is moving at around 38,000 miles per hour, which sounds unbelievably fast. But space is so vast that even at that speed, it would take more than 70,000 years just to reach the nearest star. It launched in September of 1977. The original mission was supposed to last only 4 years. The plan was simple. Fly past Jupiter, fly past Saturn, send back some pictures, then go quiet. But it never went quiet. It kept flying. It kept sending data. Year after year, it just kept going, far past anything anyone imagined. In August of 2012, it did something no human object had ever done before. It crossed a boundary called the heliopause. This is the edge where the wind from our sun finally gives up, and the true space between the stars begins. Voyager 1 pushed through that wall and entered interstellar space. Not near it, not close to it, inside it. Right now, at this very moment, Voyager 1 is floating through the plasma between the stars, measuring an environment that no instrument in human history had ever touched before it got there. It is like a lone explorer standing in a place no one has ever seen, describing it to us over a whisper of radio. But that whisper is fading, and here is why. Voyager 1 does not run on solar panels. Out there, the sun is just a tiny bright dot, far too weak to power anything. Instead, it runs on a special kind of generator that turns the heat from slowly decaying plutonium into electricity. And that heat has been fading a little more every single year since launch. When it took off in 1977, those generators made about 470 watts of usable power. Today, they produce only around 250, less than half, and that number will never rise again. It can only fall. This is not bad luck. It is physics. Radioactive material decays at a fixed rate and nothing can stop it. Every year, Voyager 1 loses roughly 4 watts of power. That is less than a dim light bulb. But when your entire budget is shrinking, even a tiny loss becomes life or death. Because of this, the team has already been forced to make painful choices. Voyager 1 launched with 10 scientific instruments. 7 of them have already been turned off. Not because they broke, but because there simply was not enough power to keep them running alongside the things the spacecraft needs just to stay alive. Heaters, the radio transmitter, the computers that turn raw data into signals we can read. All of it runs on that same shrinking supply. So every watt saved somewhere becomes a watt that keeps the spacecraft breathing. Years ago, the engineers and scientists sat down together and made a heartbreaking plan. They decided the exact order in which they would shut down each instrument. They were basically writing a will for a machine, deciding how it would die piece by piece in the way that would save the most science for the longest time, and that plan held steady for years. Until one day in February of 2026, everything changed. Now, before I tell you what happened that day, I want to ask you something. Are you enjoying this story so far? If you are, drop a single word in the comments right now and just type Voyager. I want to see how many of you are here for the journey. And while you're at it, that subscribe button is still waiting. Okay, back to that terrifying day in February. It was supposed to be a routine move. Voyager 1 needed to make a small turn to adjust its position in space. This kind of thing had been done hundreds of times over the years. Nothing to worry about. The engineers sent the command, the spacecraft received it, the maneuver began, and then something unexpected happened. The power levels dropped. It was not a huge drop. On any normal machine, nobody would even notice. But on Voyager 1, where the spare power is measured in tiny fractions of a watt, any surprise drop is a nightmare. Here is why it was so scary. Deep inside Voyager's ancient design is an automatic safety system. If the spacecraft ever tries to use more power than it has, the system kicks in on its own. It does not ask for permission. It does not wait for humans to decide. It simply starts shutting things down immediately to protect itself. And remember the communication delay. Almost a full day, one way. So if that safety system triggers, the engineers on Earth would not even know it was happening, until it had already been making its own decisions for nearly 24 hours. Decisions the team did not choose. Instruments shut off in the wrong order. Systems turned off before their time. And in the worst case, something truly critical, like the transmitter or the main computer, could be damaged in a way that could end the mission forever. The team understood the danger the moment they saw those power levels fall. They did not sit and wait to see what would happen. They moved fast. On April 17th of 2026, they made a hard choice. They sent a command to permanently shut down one of Voyager's remaining instruments, called the Low Energy Charged Particles Experiment. This instrument had been running almost nonstop for 49 years. It measured particles and cosmic rays from both inside our solar system and the strange space beyond. Its data was irreplaceable, because there is simply nothing else out there to gather it. The mission manager described the decision with careful, quiet words. He said that while shutting down an instrument is nobody's wish, it was the best option they had. Not a good option, the best of the bad ones. After that shutdown, Voyager 1 had only 2 working science instruments left. 2 out of the 10 it began with. One listens to the vibrations in the plasma of interstellar space. The other measures magnetic fields. That is all that remains of what was once the most ambitious science package ever sent beyond our world. But here is a small, strange detail that turns out to be very important. When they shut down that instrument, the engineers deliberately left one tiny thing running. A little half-watt motor. Almost nothing. Barely a flicker of power. Why leave it on? Because of what they were planning next. This brings us back to the Big Bang. The idea came from a simple but painful question. When you have already turned off 7 instruments, already shut off heaters, already worked around a broken memory chip, what is left? Where does the next bit of saved power come from? The team realized they did not need to turn anything else off. Instead, they could change how the power moves. You see, Voyager's electrical system was designed in the early 1970s. Back then, engineers built it for a spacecraft with plenty of power. So the way electricity flows through it is not efficient by today's standards. There are pathways and habits inside the system that made perfect sense with 470 watts. But they are wasteful now that only 250 remain. The Big Bang is a plan to completely reorganize those power pathways, to reroute how electricity travels through the entire spacecraft, cutting out the old waste, and squeezing out just a little more usable power. But here's the catch. They cannot do it slowly. If they change one pathway and leave the others alone, the spacecraft would sit in a dangerous in-between state for a while. And that state could trigger the automatic safety system, the exact disaster they're trying to avoid. So the only safe way is to do everything at once. Skip the dangerous middle. Jump straight from the old setup to the new one in a single instant. That is the Big Bang. And that is why it is so risky. The team knows how much is at stake. They have been running simulations for months, checking every calculation, arguing over every possible thing that could go wrong. And they made one very smart decision. Before trying this on Voyager 1, they decided to test it on its twin. Yes, there is a twin. Voyager 2 launched 16 days before Voyager 1 in 1977, but it took a different route through the solar system, visiting Uranus and Neptune along the way. Because of that path, it is actually a little closer to Earth than Voyager 1, and it has slightly more power left. That makes it a safer place to test something new. So the plan became clear: test the Big Bang on Voyager 2 first, during May and June of 2026. If it works there, if the power responds the way the simulations predict, if nothing triggers the safety system, then and only then will they try it on Voyager 1, no earlier than July. Now let me pause here for something important. If this kind of storytelling gives you chills, imagine how many other incredible space stories are out there. Instead of asking you to like and subscribe the usual way, let me put it like this. Voyager has survived for nearly 50 years by never giving up. All I'm asking is that you don't give up on this channel either. Tap subscribe, ring the bell, and stay with me. The best part is still coming. One of the scientists who worked closely with the instrument that was shut down said something that stuck with me. He said they still hold out hope that the engineers can find a way to power it back up, so they can keep learning whatever surprises await Voyager in those distant regions. Whatever surprises await, those are not empty words. Because if there is one thing Voyager has taught us again and again, it is that space is full of things we never expected. Every single time scientists thought they understood what was out there, Voyager proved them wrong. Since 2017, it has been picking up a strange, steady hum in the plasma of interstellar space, a constant vibration stretching across hundreds of millions of miles that no one predicted and no one fully understands. At the edge of our sun's bubble, Voyager found a wall of blistering heat, with temperatures reaching tens of thousands of degrees, in a region everyone assumed would be cold and empty. It found unexpected connections between the sun's magnetic field and the magnetic field of the galaxy itself. None of this was in the textbooks. All of it came from data that scientists were not even sure they would be able to collect. So when a researcher says he hopes Voyager can keep going to reveal more surprises, that hope is built on nearly 50 years of proof. This little spacecraft keeps finding things nobody knew were there. And this is exactly why that tiny half-watt motor was left running. If the Big Bang works, and if enough power is saved, that shut-down instrument could actually be switched back on. The motor was a small act of hope, a door left open, just a crack, with one foot holding it in place. While all of this drama unfolds, Voyager 1 keeps flying. And it is approaching a milestone that no human-made object has ever reached. On November 18th of 2026, at about 2 in the morning California time, Voyager 1 will be exactly 1 light day away from Earth. 1 full light day. Let me explain what that means, because it is mind-bending. Light is the fastest thing in the universe. Nothing can travel faster. And it will now take an entire 24 hours for light itself to travel from Earth to Voyager 1. So a signal sent this morning would not reach the spacecraft until tomorrow morning. And its reply would not come back until the morning after that. A single question and answer now takes 2 full days. Think about what that means for the engineers. Every single test, every command, every check costs 2 days just in travel time, before any real thinking can even begin. When that power drop happened back in February, the team could not react instantly. They sent commands, they waited, they studied the replies, they sent more, they waited again. Understanding one problem took days, not minutes, and that is the world they are working in. A first ever procedure on the oldest spacecraft ever flown, tested on one probe and then attempted on another, separated from home by a distance so huge that even light cannot cross it fast enough. They cannot watch it happen. They can only send the commands, wait, and hope. Now let's talk about why any of this actually matters. Not just for space fans, but for all of us. That mysterious hum I mentioned, the steady vibration in interstellar space, is one of the biggest unsolved puzzles of the entire mission. Scientists have 2 main ideas about what causes it, and both would change how we understand the space between the stars. To figure out which idea is correct, they need more data. The instrument that was just shut down actually helped with this. It measured particles at the same time the other instrument measured the plasma waves. By comparing the two, scientists could learn far more than from either one alone. With it turned off, that comparison is now lost. But if the Big Bang succeeds and the instrument comes back to life, that missing piece returns. And here is why this puzzle is not just for scientists to enjoy. The space between the stars is like an invisible ocean that our entire solar system floats through. Its properties shape the giant protective bubble around our sun, the shield that guards every planet, including Earth, from the harshest radiation of the galaxy. If that ocean is more wild and more chaotic than we thought, then our protective shield is less stable than we believed. And that shield is part of the reason life on Earth was able to grow and survive in the first place. So understanding what Voyager is measuring right now is really part of understanding our own story and our own future. This is where the true weight of the situation hits you, because there is no backup. There is no other spacecraft ready to take Voyager's place. When Voyager 1 finally falls silent, sometime in the early 2030s by current estimates, there will be nothing out there to replace it. Nothing in interstellar space, nothing even close to the edge, nothing able to send us live measurements from that region for decades to come. Scientists have dreamed of a new mission built for exactly this purpose, with modern instruments instead of 1970s hardware. The idea is strong, the support is real. But as of now, it has no budget and no launch date. It is only a proposal on paper. And even if we launched such a spacecraft today, using the fastest possible route, it would still take around 25 years just to reach the edge. 25 years. So the gap between Voyager going quiet and any replacement arriving is not measured in months, it is measured in decades. During that gap, the map simply stops. The live data stops. The questions Voyager has raised will sit unanswered in the silence. The mysterious hum will stay a mystery. The map of interstellar space will freeze, half finished. This is what the Big Bang is really fighting to prevent. Not just the loss of one instrument, but the loss of the only living connection humanity has to the space between the stars. Before we reach the final part of this story, I want to say one quick thing. If you have made it this far, you are genuinely one of the curious ones. Most people scroll away. You stayed. So here's my simple ask. Share this video with someone who loves a good real-life survival story, because that is exactly what this is. And if you haven't yet, subscribe, so you're here when the answer finally comes. Now, let's finish this. Here's the thing that gives me hope. The Voyager team has stared down the end before, and they have found a way through every single time. In November of 2024, a simple command accidentally triggered the safety system. The spacecraft switched to a backup radio transmitter that had not been used since 1981. 43 years of silence. No one currently on the team had ever operated it. And yet they figured it out. They brought the spacecraft back. In late 2023, Voyager 1 suddenly began sending back garbled, broken data for months. The cause turned out to be a single damaged memory chip, worn out after decades of cosmic radiation. To fix it, engineers had to rewrite the spacecraft's software, breaking it into pieces and storing it in different places. All through that brutal 2-day communication delay using programming languages older than most of the people on the team. It took months, and it worked. Again and again, this team has faced problems that looked impossible, and again, they have found answers anyway. 49 years of refusing to give up. The Big Bang is just the latest chapter, the boldest one, the riskiest one. But history is on their side. So here is where we stand. The tests on Voyager 2 are happening now, in the summer of 2026. If they succeed, the attempt on Voyager 1 follows in July. Somewhere between now and that one light day milestone in November, we will get our answer. We will know if the Big Bang worked. We will know if that shutdown instrument came roaring back to life, or went dark forever. We will know if Voyager 1 bought itself more precious years, or began its final quiet fade. And you will want to know too. Not because it is just a spacecraft, but because of what it represents. Nearly 50 years ago, a group of engineers built a machine they thought would last 4 years. It has lasted 49 and counting. They built it to speak, to carry a golden record of human music and laughter, sent into the dark in the hope that someone, someday, might find it. They did not build it to make discoveries. They did not build it to raise questions that would take decades to answer. They did not expect it to find a mysterious hum or a wall of fire at the edge of our sun's reach, or invisible magnetic bridges between our sun and the galaxy. But it did all of that, and it is still doing it. Right now, a team in Pasadena is attempting the most complex power maneuver ever tried on a spacecraft this far away. They are using a plan they nicknamed the Big Bang. They left a tiny motor running as a symbol of hope. They are working through a delay measured in days. And they are doing all of it to keep alive the only human-made ears in interstellar space, for as long as physics allow. They have not given up. The signal is still coming. That signal is still crossing 16 billion miles of empty space. It takes a full day of travel at the speed of light just to reach us. It is so faint that only the largest antennas on Earth can hear it. But it is still there, and it is still worth listening to. So, if you want to be here when the result finally arrives, stay with this channel. We will bring you the real story, the true facts. No fake signals, no made-up secrets. Just the honest, incredible reality of what is happening out there, told with the respect it deserves. Because somewhere far beyond the planets, past the edge of everything we know, a small, tired, brilliant machine is still whispering. And as long as it keeps talking, we owe it to those who built it, and to ourselves to keep listening.